Teresa went skydiving. The graph below describes Teresa's height measured in meters as a function of time measured in seconds. So let's look at this graph over here. It's actually quite large, so let me zoom out a little bit. And we can see that at time 0, her height is 700 meters. And then as time increases, as we move to the right, her height is decreasing. And her height is decreasing at faster and faster rates as we move to the right. So the rate of decline of her height is quite steep as we approach 10 seconds after she jumps. And then we can see all of a sudden, her rate of decline slows down. She's still declining as we move forward in time, but she's declining at a slower rate. And so, or you could say she's declining at her height is changing at a less negative rate. It's quite a negative rate right over here. It seems roughly a fairly negative rate, but then it becomes a less negative rate right over here. Her height is changing at a less negative rate, and it makes sense that this is when she deploys the parachute. So after 10 seconds, she deploys the parachute. So she jumps at 0 seconds, 10 seconds, she deploys the parachute. All right, but let's see what they're actually asking us. They say, complete the following sentence. Between 3 seconds and 8 seconds after Teresa jumped, her height decreased on average by approximately blank meters per second. So between 3 seconds and 8 seconds. So at 3 seconds, so time is 3 right over there. So let's see what h of 3 is. What is her height at 3 seconds? And I'm just looking at a graph, so I'm going to have to ballpark it. So at 3 seconds, her height looks pretty close. It's pretty close. We just have to approximate it. So her height, the height after 3 seconds, looks like it's about halfway between 600 and 700. So it looks like it's about 650 meters. And then we care between 3 seconds and 8 seconds. So our height at 8 seconds, let's look at that. At 8 seconds, let's see, this looks about halfway. It looks about halfway between 350 and 400. So I'll say her height at 8 seconds. Actually, since I'm approximating it, let me put a little squiggly equal sign here. Her height after 8 seconds looks like it's approximately 375 meters. 375 meters. So what is her average rate of change? Her height decreased on average by approximately. So what we want to do is we want to figure out the average rate of change, which you could view as the slope of the line that connects these 2 points. The slope of this line is going to be her average rate of change. So let's think about that. Her average rate of change, her change in height over the change in time for that interval. Well, her change in height at 8 seconds, she is at, let me write it this way. Her height at 8 seconds minus her height at 3 seconds. So this is going to be her change in height. And the change in time is 8 seconds. She finishes at 8 seconds. Minus where she started, or the interval that we care about, starting at 3 seconds. And so h of 8, we already said, this is approximately 375. h of 3, this is 650. And then, of course, 8 minus 3 is going to be equal to 5. I just want to emphasize, this is just her average rate of change, her approximate average rate of change over this interval. As we go from 3 to 8 seconds, our height goes from h of 3 to h of 8. So this is going to be, let's see, 375 minus 650. Let's see, if it was 375 minus 675, it would be negative 300. And so this is going to be, but then we're not subtracting 675, we're subtracting 650. So it's going to be 25, it's going to be 25 more. So this is going to be negative 275 over 5. Now, let me make sure I did that math right. So it's 375 minus 650 is negative 275. Does that make sense? Let's see, 275 plus 375 would be 650. Yeah, that is right. All right, so let's just figure out what this is. So 5, I'll just figure out what 5 goes into 275, and then we can remember the negative. 5 goes into 27 5 times. 5 times 5 is 25. Subtract, we get a 2, bring down a 5. 5 goes into 25 5 times, and then we're not going to have a remainder. So this is going to be equal to negative 55 negative 55. And the units, her height is given in meters. So this part up here, this is in meters up here, meters per second. So her change in height, her average change in height over, or the average rate of change of height over this 5 seconds, is negative 55 meters per second. One way to think about it, the slope right over here, the slope is equal to negative 55. Now, it might be tempting to just write negative 55 right over here, but let's just think about whether that would be right. Between 3 seconds and 8 seconds after Teresa jumped, her height decreased on average by approximately negative 55 meters per second. And decrease is important because they're already saying that it's decreased. When this negative is telling us that we're decreasing at a rate of 55 meters per second. Our average rate of change is a decrease. Our average rate of change of height over time is a decrease of 55 meters per second. Well, the negative is already saying the decrease. So we're not decreasing at a negative rate of change. We would be decreasing at 55 meters per second. So let me just write it 55 meters per second. If they asked her height, if they asked the average change of height, the average rate of change, let me write this, the average rate of change of h over, or let me say of h from 3 seconds to 8 seconds, well, now this would be negative 55 meters per second. But when they're saying that her height decreased, that's already taking the negative into consideration. They're saying it's definitely decreasing. That's what the negative is already telling us. It's decreasing by a rate of 55 meters per second. Hopefully that makes some sense.